and we'll see like how really the challenge of big data is getting solved using Hadoop. Okay, so during this session, I might ask a few questions, but I request everybody to put your questions, or even if you are answering something, so try to use the chat as much as possible. Okay, so we get a good audio quality. If really required, you can just unmute yourself and you can speak. Okay, so let's start with,
Dheeraj,
yeah.
before this is Praveen, if you don't mind, can we can anybody record the session?
Yeah, I'm recording this.
Okay, perfect. Thanks.
All right, so let's start with the concept of big data. Now, can we just start with a question like, what is big data? What do you think about big data? I know some of you are already familiar with this, but can you just put your thoughts in the chat? What is this big data all about? What you get out of the word of big data? Because everybody is
Uh,
okay.
if okay, I don't know, like do I remember any original definition? But maybe somewhere I heard that when data growth in terms of volume, variety, and velocity, it's getting too much, and everybody's expecting data tsunami, and I think we started already.
Mhm.
And so challenges of handling this kind of thing that comes into big data.
Right, perfect, perfect. Yeah, thanks for this. Very good. So that's a perfect definition of big data. That the data is growing in not only in terms of volume but also in terms of variety. Okay, so volume. I mean, if even if it was only volume, so we could have and put up more and more powerful server and something we would have got around this. But it's not only volume; it's different variety of the data, which is much more challenging. Okay, so that's why it was very crucial to think of an alternative which has a capacity to store a lot of volume, also to process any format of data. Okay, and while doing all this, it was very useful, or it was very important that the solution that we are coming up, it should be a very cost effective one. Okay, so that's the reason why we have technologies like group into picture. So let's try to understand more what we have in it. So the question still is it like why we are talking about this now? Okay. Now we talk about this now because in the last few years we have seen a lot of emerging technologies. Like somebody said that with the evolution of smartphones, the data volume has gone very high, and they cannot afford with the traditional way. So they are trying to shift to big data technology. Right. So yeah, definitely, if we think about smartphone, they are one of the leading contributor in the big data space. Okay. Then we hear a lot about cloud computing. Okay, which is again generating a lot of data because the small enterprises who cannot uh, like before introduction of cloud computing, the companies who could not afford to have the infrastructure in place and all for different R&D projects, so they have also um, they have moved to the cloud, and they are doing a lot of R&D projects, and there are a lot of startup companies who are also contributing a lot of data. So that is one aspect, and then we have social media coming into picture. So people just put so much of instant messages, the video, then images, right? So all these new trends of the technologies have resulted in explosion of the total data uh, that we generate today. Okay, so we generate a lot of data. Data has valuable insights, valuable information in it. Okay, so anybody who is looking out to find out some information, or to do some analytics, or to take the business decision, they have an option available to really go look, mine this data, find out some information, and then use for different purpose. Okay, so this slide just says what happens in 1 minute. So we get more than 98,000 tweets, 695,000 status updates in the Facebook, 11 million instant messages, data sent. So smartphone is one of the leading contributor, the one which has availed this instant message to flow all across. And then there are a lot of emails and data coming out from the traditional technologies like client servers and the transactional systems that we have today. Okay. So data coming out from all across the universe. Okay. Now, what is this big data all about? Now, this again, if you just categorize it across different vertical about what is it all about. So the first thing will be the volume. Okay. Volume is something which starts with terabyte. Okay. So there is no MB or GB over here, right? So only if the volume goes beyond terabyte, it flows to petabyte, zotobyte, yottabyte. So if we have a data in this range, okay, then we categorize this as a big data or a big data problem because below few terabyte, I mean, if the data is in few GB, so we are like our existing system that we have in place, they are very much capable or very highly evolved to store and process the data of that range. Okay, but anything goes beyond terabyte, it gets a big challenge for anybody or any traditional system to work on. Okay? So definitely, volume is one of the uh, thing that categorizes a big data. But along with volume, there are some non-traditional data types that are also coming up. Okay, so now we see the data in the form of blogs. People write so many blogs, text messages, chat messages that we do in the social media. Then lot of images and the videos uploaded very readily with the evolution of the smartphones. Then data coming out from the system logs. So as we see more and more penetration of internet, every business we see nowadays they are made online. We have website for everybody. Everybody is giving their online offering, right? So the more and more business moves, the more and more they go towards internet, the more and more they become online, right? So everybody will be generating a lot and lot of log messages or log files, okay? Because whatever we do, all the activities for the web server, they get logged into the messages log files. Okay? So if they have to really go look and analyze what is happening in their business, so they have to find the information which they have trapped in their log files. Okay. So these log files again, it is like terabytes of the data that gets generated every day. And if somebody has to really pull all the logs and analyze it at a very small time quickly to find out the insights, then again it's a challenge or it's a big data challenge. Okay, so big data is more of a challenge. Big data is a problem, right? So since the things have come up in this way, so big data has become more of a problem statement for anybody. So they say, okay, I've got a big data problem. Whenever enterprise feels that they have got a big data problem, the next step is they look for the solutions. What are solutions they have for this problem? So the problem is definitely in terms of volume, okay, in terms of scalability, in terms of different variety of the data that needs to be handled. Okay, so and again, one of the thing could be like they want a very cost-effective solution for their data warehouses or whatever, right? For data storage or to meet up the ever-increasing demand, right? So because generally what happens is if we keep on storing the data on existing servers, right? So we keep on filling them very very fast and procuring a lot of server, we end up losing a lot of money. Okay. So if we have to look for a cheap storage or a very cost-effective solution of storage as well as processing, so we have to look out for the technologies like Hadoop. Okay. So what are the data sources? We looked into data sources like cloud computing, smartphones, okay, social media. Apart from this, we have data coming out from the sensors, which are which have become very common nowadays, right? We see sensors attached to the car, sensor to the any automotive and machine gadgets, right? So everybody comes up with sensors which continuously sends the data to the server, right? Then we have data coming out from the RFIDs from various devices, and of course we have the traditional applications which continuously sends the data, right? And then we talked about the web servers which put a lot of data in their log files, right? So there are so many different sources of the data. There are the problems, right? But the question again, it comes out that why do business really think about moving to the big data? Okay, so some of you already have experienced this, that why companies are thinking to go over big data is because they, their existing solution or their existing application, they cannot afford to process the data when it goes beyond a limit. Okay? So if I mean, let's say they were happily doing something with some few terabytes of the data, but if the data has gone beyond the limit and now application which was taking, let's say, 5 minutes or 10 minutes to perform some job, now it is taking 2 hours or 5 hours. In some cases, there are applications which even takes 2 days, 3 days. This kind of applications they have, right? Because the volume of the data that they are supposed to process, they have gone very, very high. Okay? And none of the business can afford to spend so much of time in processing their data if they have to really be a competitive or to be a very uh, to really look into what is going around and to find out very quick insights, right? So that's the reason why the first step is they want to come up with the performance bottlenecks which it comes with the existing applications or the traditional technologies which we have been using so far. Okay? So that's why a lot of enterprises they are moving towards big data. The second type of business who are moving on the big data is, let's say, they already have some of the warehouse which stores and which like keep on accumulating data every day. Okay, so and they are using a solution which is provided by IBM or Oracle, right, for their data warehouses. Now, if they have to think of an alternative because these solutions are very, very expensive. All the data warehouse that comes in Netezza or Teradata, right? So they are not that cheap products. They come with expensive hardware. They come with expensive software, right? And maintenance support for them is also very, very expensive one. So if they have to think of coming out of the licensing cost and moving out for some a cheap product which can scale out very quickly to serve their need, okay? So they quickly adopt Hadoop because they find it to be you know an alternative which is very, very cost effective and which scales out very, very readily, and the infrastructure which also they can procure in house instead of relying on hardware which comes with some third party team. So they can just put their own infrastructure, they can buy their own, and they can build their own data warehouses very cost effectively. So while they are doing all this, we have also some uh, business customers who are looking into some insights inside the data which comes out in their business. So the third category of the people who are moving into the Hadoop or big data technologies are the people who are looking out for how how is their business performing, how they can predict something, okay, how they can be more and more competitive in the market. How can they how can they use the concept of big data analytics to serve the customer needs or to understand the customer sentiments, okay, to find out how is their brand performing in the market, right? So then this type of people, if they want to go for analytics, which need to process lot and lot of data. So they also move to this big data technologies. So there are multiple insights in it, and there are different use cases which different enterprises have. But the fact or the reality in the ground today is that everybody is talking about big data. Many of them have already thought that Hadoop is going to be their solution for the big data, because Hadoop is it has emerged as a single major player in the big data technology. Okay? So there are like it is like a standard, right? So if they have a big data problem, so as a standard, they say, okay, you have to go with Hadoop. Okay? There is no so much of alternative to the Hadoop, and that's the reason why this particular technology is getting so much of attention nowadays. Now we talked about what is big data. We talked about different variety of the data. We talked about why we talk or what are the different business cases associated with it. Then let's talk about the technology. Now, what do we need with the technology? Okay? So we are talking about a new technology or something which is new, not which is not in a traditional fashion. So the first thing that we need from the technology perspective for um, coming up with a big data solution is that whatever technology it is, it should be highly scalable, because nobody can predict what would be the data volume after 5 years or 2 years. Okay, so whatever is a solution, it should be highly scalable. So if I've got 1 terabyte of data today, and tomorrow I'm getting some one another terabyte. So if tomorrow I'm getting two terabytes of the data, so it should not be like oh, I my hardware cannot support that, so I have to again raise a request for a new server, and then it's going to take few months to buy the servers and procure it in another few weeks, and then installation and all right. So nobody can afford this much of time if we have to think of a big data solution. So whatever solution, it should be highly scalable. The second most important thing of a big data problem is that the processing, it cannot go by one computer. So we have to think of a distributed parallel processing. Okay, because if even no matter how much of money we spend and how powerful server we procure, okay, it is going to take time to process the data. If I have got some petabytes of the data, it's going to take time to process that. It's going to take that time to read the data, process it, and then write the output, right? So these things we cannot get out of no matter how much of powerful server we use. So what is the solution? If we have to process a lot of data at a very small time, so the solution is to go with distributed parallel processing. Okay? And that is what uh, all the big data technologies that talk about distributed parallel processing of the data. And Hadoop also talks about the same. Okay? And definitely the economics of whatever solution that comes out, it should be a very cost effective solution. All right. So was that clear? Any questions? You can always, if in case you have any question, you can put your questions in between in the chat. So I will be replying to that. Okay. Okay. All right. So we looked into how does big data helps business to engage more. Uh, let's say we have got interaction data from the emails or chat transcripts. Okay. So if my customers are interacting with a business via email or chat, and if I have to look what is going around in the and I have to understand the problems of my customers or their ask what they are looking for. So I have to process this format of the data to look into the interaction data. If uh, if I want to be more smart and I want to see the web click stream, so this is something whenever a user visits a website, so he he uh, he leaves uh, you know like all the activity whatever a user do, so everything gets logged in the web logs. So where how many users came, who is the user, which from which IP address this person logged in, okay, which location, and then what exactly he visited, which where all the person has clicked. So all the activities getting logged in. So if a business or if I'm doing some business and I want to look how many people really turned up, how many of the people they visited my website, okay, what each of them they really did. So if they have browsed some product or they have looked into some offer or some service, right? So I come to know that this particular person is interested in this particular product, okay. Then I can see, okay, did he really purchase this product or what he did with that? If he just looked into that and he went out, so it gives me one opportunity to, um, or it gives me a person who is really interested in something, but he did not buy it because of any reason, whatever it could be, right? So now, as a business, I can really go and interact with the person. I can just give some more promotional discount on that particular product that he is interested in, right? So I can do a lot of things if I really know what the user are looking for. Okay, so how is that possible? It's only possible if I have a capability to process the terabytes of the data which gets logged in and to mine it, to process it, to find the business insights that we have. Okay, so and that definitely involves a technology which can process a lot of data at a very small amount of time, and because this data it comes on like it gets accumulated every second, right? So whatever solution or whatever technology we are looking for, it should have. And if we are doing some historical analysis or let's say analyzing a data of one way, so I should have a capability to process a huge amount of the data that gets generated and to quickly find out the insights or to do the analytics. Okay? Then, if you look into the social media, and if I have a capability uh, to store and to process what is going in the social media, right? So it gives a lot of competitive advantage to any enterprise. Why is it so? Because whatever whatever goes around, right? So if uh, a new handset is coming up or a new service or any product is coming up for any company, right? So that gets a trending word in the social media before it gets launched or before or just after it getting launched. So people talk a lot about the new product or any new movie or anything new that comes up. Okay? So if I can go look around what is going in the social media, I quickly get an insight like what are the things which the end user or the consumers they liked about it. What are the things they are looking for improvement? Okay. What are the things? What are the needs and the desire and the customer sentiment? Right. So it gives me a way to look into the sentiment of the customers. So this is how if I have an ability to process a big data, it helps to engage business more and more. So it gives a lot of advantage to the business to be more and more to understand their consumer well. Okay? So people nowadays they talk about 360 degree of their consumer. They want to understand what each of their consumer is doing all around. So what are their interests? Where all they are visiting? Uh, what they are doing? What is their buying behavior, and there's a lot of things which business they are more interested to understand their customers well, so that they can serve them well. Okay? All these things definitely require to collect a lot of data, to store a lot of data, store it for a longer time, and then to process it. Now, multiple use cases we have for Hadoop. If we talk in terms of growing revenue, so like something like social media analytics, okay, which has me to look around what is going on or to understand the customer sentiments well. Then recommendation engine. So this we see in all the e-com websites. They say that people who purchase this, they also purchase this. Uh, like this kind of recommendation. Also we see in Facebook, LinkedIn, right? So these recommendation engines also they need to process a lot of data, reconcile a lot of things before coming up with a solution. Okay. So and then personalization that we see like a user's screen is designed based upon the needs and desire or interest of a particular user, right? So personalization of the screens, right? So these are few things which has to grow the revenue. And then in terms of reducing the risk, so fraud detection, fraud prevention, financial, all a lot of big finance companies, insurance companies, they go for this. And then to improve the operational efficiency, we have multiple use cases like web index and searching. So this is what Google has come up to index up the things as much as possible, so that the search result it takes up very few minutes, right? So they can process a lot and lot of data in a fraction of a second, and they come up with the search results, right? So image processing, data aggregation, pre-processing. So multiple use cases we have across different verticals. Okay, so these are the different sectors, and there are some of the sample use cases. Okay, so anybody working on any of the retail project or banking project, healthcare, energy, anybody? Do we have anybody who is really familiar with the use cases that is going around?
I think OTSI, whatever people in this call, I think all are from telecom background from last couple of years. I have worked for healthcare, but years back. Like I think data was not the challenge that time.
The healthcare,
But
in the healthcare,
yeah,
right? Okay, so let me tell you,
correct. No,
healthcare. If you talk today, so healthcare are one of the biggest big data users. Okay, this particular segment has got a lot and lot of users in the big data healthcare, and lot of big like United Health Group has come up in a big way. They have invested a lot. Okay, and this is what their project has already started. They have already started doing a lot of use cases in the big data and multiple other healthcare big data, big hospitals. They are coming up with a lot of use cases in the healthcare. So all of you are in the telecom, right?
yes,
Now telecom, they generate. Now the beauty about the telecom is that they generate a lot and lot of data every minute, and their data is not something which you we have to really go look around and mine some to get out some small amount of information, but they have got a lot of informative information. Like if you look into CDRs, now they contain so much of information in it. Okay, and like in telecom, people are going for network analytics to understand the CDRs well. So what are use cases that we have in telecom, which OTSI is doing? Anything which is which has started, or any plans of moving on?
Okay, I'll tell you that there are two type of main projects we have, Reveal and Flux. We are, for so many reasons, we are supposed to save every single record for a certain number of days. And the use of the data, it's like multiple uses are, identifying that what cell tower if you drive around, on the roadside, you will see the cell towers may have capacity problem where maybe it is short out of capacity, or maybe the capacity is wasted there, and where tuning is required, and if the customers are experiencing that too many drop counts are there. So with our application, they, like, people don't, that the field engineers and the technician, they don't have to go and find that where is the problem. Even the people sitting in India, in I think Ericsson Noida, they are looking our data, and then they can pinpoint that where exactly that there is a problem with the towers. So this is one, and for if any mishappening happens, like murder or kidnapping, so we get these kind of requests from different people, and we not directly, but through our legal department, they get this information, queries, and we try to help finding that, okay, what was happening with the victim's phone, or maybe the person, if somebody is trying to trace. And these type, and we are generating some reports, like for a particular vendor, OEMs like Apple, so how their phones are performing. So that helps getting aligned and getting more working with Sprint. So these are similar to some cases. And if you since you're saying that in the 5 minutes, in some of the feeds, we are I think crossing billions of record in 5 minutes itself.
Absolutely. So it depends upon how big a telecom is, right? So every minute, yeah. So there are billions of. See, this is not only about CDR, right? So there are so much of information that generated along with CDR. There is signaling information. There is data coming out from. So if one call is more made, it generates more than 30 different records, which has to be by telecom regulatory. It has to be retained. Okay, so none of the telecom can afford to pass their data. Okay, at least they keep it for 7 years, or I think since 2007, all the data that all the calls that are made in the US, so everything is retained, right? So that is a regulation, and right, as you said, like if anything it goes wrong, so the data comes out, like to really go look around what has happened, where this person has made the calls and all that. So all these things need that the data, whatever we have generated from the telecom, is retained, so that for any historical reporting or any analysis, it can be readily used. Right? So yeah, there's a lot of data, and telecom are one of the big users of the big data, because they cannot go out with this. Okay, and if they have to store the data, they have to look for some data warehouses where they put all the data. So the first thing which they can do is they can just move out all their data warehouses to scalable solution like Hadoop. And if they have to run the reporting on the historical data, right, which take a lot of time, or any sort of analytics which they want to do on the data which they have collected, right? So Hadoop is one of the favorite use case, or one of the favorite technology which they can move on. So telecom, a lot of use cases are there, but it's not only the telecom that is leading in this space. Retail is also doing multiple use cases, like they want to understand what is the consumer's buying behavior. So whenever a consumer buys, before coming up with some promotion or discount offering, okay, so they want to do some sort of uh, they want to just understand, like what a particular customer is really buying. Okay, so what are his prime focus areas where he really go and purchase the product. Okay, and based upon that, they want to personalize the promotion or the discount which they offer. Okay, so if a discount makes sense to me, so I get more happier, right? So let's say I'm getting a discount on the product which I regularly buy. So that is more helpful than some other discount which really doesn't matter for me. Okay. So this kind of effective campaigning of their product, right? So these things which they do in the retail banking, generally mostly used for fraud detection and prevention and for end-to-end trade reconciliation, right? So if we look into, so many transactions happens every day in a particular bank. Okay, so there is money taken out from a particular account and then deposited from another account and then taken out from there, right? So at the end of the day, all the banks need to reconcile what has happened, okay, throughout the day. So while they reconcile this, they have to process lot and lot of data to just match all the plus minus, they sum up to zero or not. Okay, so this end-to-end reconciliation, um, which involves processing lot and lot of data, so we can use Hadoop for that. Then the multiple, yeah, question.
Dheeraj, one quick, for I can give you one very good example that happened with me 2 3 days back, 2 days back rather.
Yeah,
I have credit card of the U.S. third largest bank, Wells Fargo, and I got one message that my transaction is declined. I was not even doing any purchase, and all of a sudden I got one more message. Okay, your transaction is declined. Then I went to a store just to check. Yeah, it declined that transaction also. Then I called my bank. They are saying they are sensing that my card has been hacked, and they blocked my card. They were trying to reach me out, and in just 5 minutes there were 50 attempts on my card. So even I was surprised that even like how bank has so many customers, right? And US 30, the third largest bank, how efficiently they are able to identify that my card has been hacked, and they
right.
blocked, and yeah.
Right. So this happens with a lot of persons. So let's say you swipe today in US and tomorrow you go to UK and then you swipe it, right? So your card will not work because they also track uh, if a user regularly swipes on a particular geography and all of a sudden the geography gets changed. So I mean, the algorithm is like it understands that this could be a fraud, okay, and then they try to prevent that transaction. So this happens online. Okay, I mean this happens on the fly, which needs to process so much of data. Just imagine that it is understanding. It first try to analyze your current location, and then it want to map with the location where you have started now, and it does it for all the customer, and then it comes up, and it also sends an alert and also blocks your transaction, right? So this has to go so fast. Okay, so, and that's the reason why we are talking about the technologies to understand how. Okay, yeah. So generally for fraud detection and prevention, it is used, and in manufacturing. So a very good example was who gave us that example is Praveen, right?
Yeah.
Okay, yeah, yeah. Thanks, Praveen. Hmm. So healthcare, we took some examples. So also in a big hospital, what they are doing is they are putting up the gadgets which uh, like big hospital, they have got millions of patients who every day there are millions of the patients at any particular point of time across the globe. Okay, so if they have to really send out the uh, doctors or nurses to take the vital body parameter, which is just for a routine checkup, like how each of the patient is doing. So that is a very challenging task for the big hospitals. to really be on the time if something goes wrong. Okay, so instead of whenever something goes wrong for a patient, so instead of somebody or relative or the patient really calling somebody or a doctor reaching out that place, so what they do is they put up the gadgets on the patient's body, which continuously sends the vital information like heartbeat or body temperature, pressure, right? So all these things which define how good health of a particular patient is, right? So these parameters. So every and they set up a time like every send this every 5 minutes, right? So these sensors it collects this information from the body and it keep on sending. So and they have a central server which takes all this data and it is analyzed on the fly. So if anything goes wrong, right? So automatically an alert will be triggered to the concerned person or to the particular department to take the required action. Okay, so this is one thing, but there are a lot of use cases in the healthcare. Like one of the big uh, hospital in Massachusetts, so and that's a cancer hospital. So what they have done is whenever a patient visits in, okay, so whenever a patient come in, they want to map his genetic information with the genetic information of their existing patients, okay? Because in cancer the genetic information or the genome data it matters a lot for what kind of treatment will suit a particular person, right? So instead of going uh, for a very generic chemotherapy to treat up the patient, they want to analyze the genetic information and they want to see what kind of treatment has helped an existing patient of the similar kind of genes. Okay, and then they want to give the similar sort of treatment so that the patients recover very quickly instead of doing some hit and trial and putting a lot of time in uh, finding out the right drug. If they can very do it if they can just analyze some data which already resides and they can quickly give some very effective medication to the patient, so that helps a lot, right? So healthcare sector is going very big with the big data. And then we have energy sectors where there are multiple use cases like companies like O Power or Vestas, right? So Vestas is one of the wind power plant. Okay? So if they have to come up with a new plant or they want to build a new wind power plant, so it's very crucial that they analyze how the weather has been in that particular new geography since last 100 years. Okay, and based upon that, they want to predict how the weather condition would be for the next 20 years, right? Because their output it depends only about the weather, like how much is the wind velocity, how much, what is the precipitation, humidity, temperature, right? So these are very vital parameters for them. So if they have to do some predictive analysis, they have to first understand the pattern, how the weather has been, right? So, and which involves a lot of uh, data to be processed, which is collected from the different weather stations, right? So, Vestas they go with the implementation of big data to understand or to analyze the weather condition or to predict for a new geography before setting up a plan. So these are just sample use cases, but everybody over here, if you all understand that there are different use cases for different verticals, and this is just a uh, uh, they are just they are just a few sample ones which we have picked from some of the very leading sectors that we have today. Okay, So with this, we talked a lot about big data use cases and all. So now we'll move on to Hadoop. Okay. We'll we'll talk how does Hadoop come into picture. But before that, any questions anybody want to put? Okay, so no questions. Let's move on to the Hadoop creation history. How does Hadoop come into picture? Okay. So this started in the year 2002 when Doe Cutting and Mike Caffarella they were working on their pet project which is Nudge. Right. So Nudge is it's an open source web search engine. So Doe Cutting and Mike Caffarella they were working on this project when in the year 2003-4 Google published the paper of Google File System and MapReduce. So this concept it talks about parallel processing of the data, like distributing a data and to process it parallelly. Right? So when Doe Cutting understood or when Doe Cutting read about MapReduce concept, he got inspired and he tried to use the similar concept in his project, which is Nudge, and he got a very good result out of it. Okay. So till 2004, Hadoop was not the primary project. It was just a sub project of a dog cutting which he was working on. But later in the year 2006, when dog cutting joined Yahoo, and with the help of Yahoo, he started working on the Hadoop. And in the year 2008, he was able to come up with the fastest shot of 1 terabyte. Right, so he just shorted out 1 terabyte of the data in 3.5 minutes. And for doing this, he used 910 nodes. Okay, and this node is nothing. So what are the nodes? What does this node really mean? We have some people who are already familiar with the node concept. Right? So can anybody tell me what does this node mean?
It can be like cheap computer and that hard that blade kind of configuration that each blade itself it's a one node. So cluster of those nodes and entire processing is happening across those nodes.
Right.
So whenever you request the data, all stuff on a request goes to all nodes and starts processing, discarding what is not needed, and that sorted out information come to the host node, and where there it gets merged.
No, no, no. It's not like this. Not like this. It's not like this. But yeah, I mean, node is definitely some computing. I mean, it's see node. We can just consider this as one of the computer. Okay. So what do we have in a computer? We have got memory. Okay. We have got storage. We have got processing power. Right. So if you combine all of this, it becomes a computer. Right. So this node is also one of the computer which has got everything. So it's a computer only, which is termed as a node in Hadoop. Okay. So whenever we talk about node, we can just relate it as a computer which has got processing power, which has got storage, okay, which has got everything that a computer has. Okay. So he what he did is he put 910 computers and made a cluster of that, and he used the power of parallel processing of data to short 1 terabyte of data in 3.5 minutes. Okay. The next year in 2009, the same result of 3.5 minutes it got reduced to 62 seconds when he increased the number of nodes from 910 to 1460. Okay, so 1460 nodes. So he just increased the number of nodes and he got a much better performance on top of this. And then he realized that it is really possible to process lot of data in seconds or minutes, which was taking uh, some let's say hours or days of time. If we divide a bigger problem into smaller units, we distribute it all across, okay, and we process it parallelly, right? So, and then the concept of Hadoop started going uh, popular with the evolution of Cloudera, right? So, And then Cloudera came up. It came up with the console distributions. Hadoop was made open source, Apache, and then all suddenly by the year 2003, uh, we start getting the commercial, the enterprise ready Hadoop to be used across the uh, production environment. So, what are all the key features that we have in Hadoop? Is the first thing is this software is open source, and we all know how open source software is picking up. Right, so nobody wants to really nowadays. Uh, See, we have seen the power of open source software with Linux. We have seen with the Android, right? So Hadoop is, and we have seen a shift of the enterprises or the customer or the users to move from a proprietary software towards the open source. And everybody they talk about open source, they want to go for open source, right? So it's an open source software which is designed to write the code for a distributed application. Uh, Second thing is Hadoop is highly accessible. Why? Because it runs on a large commodity hardware, right? So if we talk about other solutions, like any other solution, like let's say the offering which comes from Oracle or Teradata, right? So we have to, for their appliances, we have to buy their hardware, we have to buy their licenses, we have to buy their software, and then only we can and then we can just really use them. Okay, but this is not the case with Hadoop. We can just we can just download the open source software. We can put it, make it run on a cluster of our own commodity hardware. Okay, so we can just buy some hardware of our own. We can maybe make our own cluster. We install the Hadoop on top of that, and we can just start running the Hadoop clusters. Right, so it's highly accessible. Okay, we don't have to go for any enterprise engagement the with other companies and wait for the hardware to come in and wait for their support guys to get everything ready before we use it. And so this it's not the case. So that makes Hadoop very accessible because it does not involve spending so much of money. It's cheap. Okay. But even if it is cheap and we are talking about commodity hardware, which is not that expensive, so that's the reason why, and but still the Hadoop is made very robust. Okay, so architecture is such so that even if any of the hardware fails, so it doesn't stop the working of the Hadoop. Okay, so even if a lot of hardware is involved in processing of the data. Some of the hardware fails, but still it continues to work. Okay, so it's made kind of a self healing kind of mechanism is there, which and because the architecture is made very robust. We'll see how it works. Okay. The next key feature about Hadoop is it is highly scalable because it works on top of the nodes, all right, which is a single unit of computation, right? So if uh, today I am happy with 100 node cluster, and tomorrow my requirement is to add up 10 more, right? So I can just quickly plug in 10 more node and make my own cluster of 110 nodes, okay? And let's say after 1 month I don't need that many nodes, so I can just pull out uh, the access node and use it for some different purpose if required, right? So it's very scalable. We can scale out, scale down based upon the business use or the desire. Okay. And the last, not the last, but uh, another top feature about Hadoop is that it is very simple. Okay, simple because there is no very complex or very crucial or uh, very difficult code that needs to be written for working on this. Okay, it involves the code which is very simple, And finally, all of these top features, it end up on a very cost effective solution for processing big data. Okay, so these are some of the top features that we have in Hadoop today. All right, so have a look into the ecosystem that we have in Hadoop. So the bottom line of storage is a distributed file system which is distributed across all the nodes. Okay, so the storage power of each of the node is taken uh, into consideration, or the storage is something which is a combination of all the individual storage of each of the node. Okay, so this is known as Hadoop distributed file system. Okay, on top of this file system we have got a MapReduce framework, which talks about processing of the data in parallel, right? So data is stored at this layer on Hadoop HDFS. On top of this, we have a programming model known as MapReduce. Then we have the ETL tools like Pig. We have got Hive. Okay, we have a workflow manager which is Uzi, and for different algorithms like machine learning or different analytics, we have got tools like Mahout and R. Okay. There's also a NoSQL databases. Have you heard of NoSQL databases? Anybody? NoSQL database is also
Yes,
very popular today.
yes, Dheeraj. I heard so many NoSQL like, databases like MongoDB.
Yeah, perfect. So Venkat, can you just explain what is the use of NoSQL databases?
NoSQL database means let us suppose we will take MongoDB. It is a document-oriented database,
Hmm.
and we will take HBase. It is a column-oriented database. The difference between row-oriented database and column-oriented database is
Hmm.
in row-oriented databases we will store the data, or otherwise we will retrieve the data based on the rows or row keys, something like that.
Hmm.
In column-oriented databases we will store the data by using column families.
Hmm.
Like we can get the performance variation between uh, row-oriented and column-oriented databases as well.
Hmm. Right, right. Perfect, perfect. Venkat, yeah, thanks Venkat for bringing it up. Okay.
Yes,
So,
yes.
so what Venkat is talking about is he is saying that we have a column oriented database which is HBase. Okay. So we'll talk a lot when we discuss HBase, but let me just brief you what is this HBase is. HBase is one of the NoSQL database which comes with the Hadoop family. So in this family, we have a database which stores the data on a column oriented way. So this has, say, generally if we talk about the Oracle databases, the traditional RDBMS, all the solutions, they store the data in a row way, right? So one row is one entry, and then the row, right? So data is stored in a row way. But if my requirement is to pick only two or three columns, so let's say there are 150 columns in a table, okay, and my all other columns doesn't really require all the time. I make use of three or four columns, okay. So if I have to only pick three or four columns out of 150, so what is the use of or what really it makes sense to read the entire 150 columns of the data, right? So if I know that my data usage is only to read few columns, few important columns, and I, if I'm going with a column storage databases like HBase, so it gives me a lot and lot of uh, performance improvement on top of the row storage. Okay, so we'll talk about this later, but just today is just an introduction. So HBase is one of the NoSQL databases that we have, and there are different other NoSQL databases in the market also. Okay. Then we have a Zookeeper, which takes care of the coordination. We have a tool like Scoop. So if there is a data which already exists in some of the enterprise uh, uh, database solution, let's say we have data stored in some MySQL or Oracle or any other database, right? So if the requirement is to pull the data and push it into HDFS, right? So we have tools like Scoop, and also if it is required to push the data out of HDFS, store it into uh, some database, uh, relational database, sure we can use this tool. Then we have a Flume, which is used to collect the unstructured data and push it directly into HDFS. Okay, so these are some of the component, but there are a lot and lot of component in this big data family. Okay, these are just brief ones, but this particular uh, the this particular big data family is something which is evolving. So every day we find something new getting added up to this family, which talks about a new feature or some new implementation or uh, a new product which comes on a like very sure. Like this is a very fast evolving field that we have today. Okay, so
Hey, Dheeraj, quick question.
yeah, please. Yeah, Avinash, tell me.
Uh, so, so we'll be looking into each and every component in detail, right? I mean, in the previous slide, there is something called Ambari which we have not discussed.
Ambari?
So, yeah.
Oh, okay, sorry. So Ambari is
So,
see.
we'll,
Okay, let me tell you what this Ambari is about. Uh, Ambari is one of the managing or administering component that we have, which comes as a open source offering. Okay. Now in Hadoop there is open source software, and also there are some commercial players in the market. Like we have Mapr, we have Cloudera, right? So Ambari is one which is open source, which is used to monitor the cluster. Okay, and Hottenwork is the one which uses Ambari. Okay, so just like to manage all the component, we have a tool which does the administrative work of installing, managing, monitoring all these things. Okay, so what we are going to look into our classes is we are going to look into Pig, Hive, MapReduce, Scoop, Zookeeper, HPace. Right, so these are all the one which we are going to look into detail, and we are going to do hands-on on top of all of these components. Okay.
oh, thanks, Dheeraj.
Any other questions anybody want to bring up? All right. So with that, let's see what Hadoop is consist of. Okay. So the component of Hadoop, as we already discussed, the bottom layer where the data is actually stored is known as Hadoop distributed file system, right? So data is stored on a collective disk of all the node that make up a cluster, right? So from here onwards, we'll be talking more in terms of nodes, and we'll be getting specific on what type of node. Okay, so we have different types of node. We have got name node and we have got the data nodes. Okay, so this is very crucial. So HDFS is again divided into a master slave kind of architecture. Okay, so we have an admin node which is known as a name node, and then we have got multiple data nodes, right? So even if we talk about the nodes in the cluster, so we have to be more specific. So actual data will be stored in the data nodes. Okay, and the metadata information or the directory tree of the file system will be stored in the name node. Okay, then we have on top of the HDFS, we have a MapReduce, which is a programming model. So this MapReduce is consist of a job tracker, which again acts as the master, and then we have got multiple task tracker, which takes up the individual task. Okay, so the master will be assigning some tasks to the so the master will be assigning some tasks to the task tracker, and the task tracker will be executing that task, and finally it will be responding back to the master saying, okay, I am done. Okay. So this master slave kind of architecture we have both from the computation as well as the storage. Okay. So with moving forward, we'll be talking more uh, specific to job tracker, task tracker, data node, and name node, right? So this is the introduction about what all different components that we have into Hadoop. Okay. So how does the workflow happen? Now this is important to understand that uh, e- even if we are talking about the cluster which might consist of hundreds of the nodes, but a client will only be interacting with the master. Okay. So who is a client? A client is somebody who wants to perform some operation on top of Hadoop cluster, or who wants to run some program on the Hadoop cluster, right? So any client who wants to interact with the cluster, he will be interacting only with the master, okay? And the master is known as a job tracker. So master will be dividing. Master will try to understand, okay, what is the job? So once master comes to know about the job, so the master will be dividing a particular job into smaller tasks, and it will be assigning that task to each of the uh, task trackers that we have in the cluster. So have a look into this. We have one job tracker, but we can have multiple task trackers, right? So master will be one, but slaves can be in multiple numbers, right? So what it means is that we have a one job tracker and we have multiple task trackers. So master's job is as if we just relate it with one example. So a project has one project manager, okay, but there are different team members who work to complete the project. Or like one project manager or a one team lead will be dividing a work into small to the individuals, okay, to the each team member. Team member will be doing only the given work. So once all the team member perform their work, and if once we combine all of them, so that becomes like a complete project, right? So similarly fashion, we have master slave architecture where whenever a client talks to the master, master will be dividing the work into smaller tasks, and it will be just distributing it across the cluster. Okay, so each of the individual task tracker will perform their own task, and finally once we collect all the tasks, so that becomes the like that finishes up the job, and once a job is done, so that is returned back to the client saying uh, your requirement or your job is completed. Okay, now have a look. Let's say we have a data which needs to be processed. Okay, this is a bigger file which has got a lot of data. So if I have to process the data in Hadoop, okay, so the first thing that I have to do is I have to divide this bigger data into smaller units of the data. Okay, so first the data is going to be divided into smaller blocks of the data, right? So let's say the first three line becomes block number one, next three lines becomes block number two, next three lines becomes block number three. Like so, in this way, we are dividing a bigger data into smaller units or smaller blocks, and these blocks, individual blocks, can be parallelly processed by each of the node in the cluster. Okay, and once we process them, once we combine each of their outputs, so that becomes the final result, uh, which is output, right? So how do we achieve the parallelism? It's important to notice that we first divided a bigger data into smaller data, and then we process the smaller data in parallel using different nodes, which makes up my cluster. Okay, and once I process each of them, once I combine them, so I got the result, which will be many times faster if I would have processed this file line by line. Okay, so instead of uh, one computer processing the data line by line, what I've done is I've divided the work to multiple computers, which helped me to achieve the parallelism and finally to process a lot of data in a very small amount of time. Any questions on this diagram? Because this is very crucial. This is the gist of how does Hadoop work.
So, Dheeraj, can we think of reduce as like summary operation like grouping by and uh, or generating the count or aggregation.
Absolutely, absolutely. So reduce is something which is to grip up or to end up the the things to give the final result or give the final output. So you are right. Like it just consolidates the things and give us the final output.
Okay, and can you go to the previous slide where you were showing that client talking to master? Okay, so like each task tracker, is it specific to a node or it's sits on top of multiple nodes?
Right, right, right.
Like,
Right. Let me go to this particular slide. Okay. Now have a look into this. So this particular slide it explains uh, your question. Now wherever we have a data node, we see a task tracker, right? So if this
okay,
box represents a node and this is a data node, so we have a task tracker, right? So each task tracker resides on top of a particular data node. Okay. So it's not like one
okay,
task tracker for 5 data nodes. It's not like this. Okay. Each
okay, it's
data
one to
node,
one.
yeah, it's one-to-one mapping from in all the slabs. Okay.
Okay, yeah, got it.
Okay. Okay. So
Uh,
we
the,
discussed. Yeah. Any more questions?
Dheeraj,
Yeah. I can tell you. Who is it?
uh,
Avinash. Yeah.
do we have only one? Do we have only one name node, or are there cases where there can be multiple name nodes which can be configured?
Right. So yeah, it's a very good question, Avinash. I understand why you are bringing it up. See, if we have only one name node, which will mean that we have a single point of failure, right? If
Yeah.
something is one in a cluster, which means that if that goes, so entire cluster is down. So you brought up a very good concept. Like, do we have only single name node? Right. So yeah, we have only single name node in our Hadoop cluster. If we talk about the first version of Hadoop, okay. So Hadoop has till now there has been two version of Hadoop. Hadoop 1.x series, which is like 1.1, 1.2, like this, and then there is Hadoop 2.x series, which is like 2.1, 2.2. Okay, so with Hadoop 1x series, we had only one name node. Okay, so in the cluster, if name node goes down, so that was one of the problem with Hadoop 1.x, right? There was no high availability. But with Hadoop 2.0, there is a high availability of the name node. Okay, so we can configure a high available name node. So even if one node goes down, so we have another name node which can take up. You guys understand that, what is this high availability? The concept of high availability. Because in telecom, this is a very common word, high availability.
Yeah.
Like, there should
Right.
not be any downtime.
Right.
I
So there
mean,
should not be any downtime. Okay. So with Hadoop 1.x, it was a name node was only one name node. So if that goes down, so there was a downtime. But with Hadoop 2.x, that problem is also solved, right? So we have a high available name node, which has got no downtime. Okay. And data node can be as many slabs that we want. Name node will be only one. Okay. So at any point of time, we will have only one name node that takes care of serving the request. Okay. Now with now this is about the first version of Hadoop that we are talking about. There is a latest uh, Hadoop version which talks about name node federation and uh, high name node high availability. So these are topics which are very latest, but we'll discuss like how what they all talk about. But yeah, if we are talking about the classic MapReduce version, we had only one name node and multiple data nodes. Okay.
thanks, Dheeraj.
All right, so we'll see what was the problem with us only one name node, and what are how it was getting solved earlier and how it is done today. Okay, we'll just compare how the things go. So we are starting with the first version of Hadoop. We are talking about the job tracker and task tracker. Okay, why? Because this is how the things started. Okay, Hadoop started with these concepts, and many of the uh, customers, they are still going with the with this. They have this in their cluster. Now, Hadoop very recently they have come up with a yarn framework. Okay, so I don't want to confuse you now with what is yarn and all, but yeah, I will tell you, like, there is an improvement on this architecture as well, which we will discuss once we are clear with this architecture. Okay, so any other
Sure.
questions? Shall we move ahead?
Yes.
Okay, so before we move ahead, we discussed few points. So we discussed about the big data concept and how does Hadoop come into picture. So next we'll dipping dive into Hadoop, and we'll see where Hadoop actually fills in. Anybody? Okay, no further questions, right? So fine. Let's talk a lot more about this Hadoop before we come to the conclusion. Okay. Now have a look into this diagram. This talks about two dimensional, or in X series we have increasing data variety and complexity, and second on the Y axis we have the volume. Okay, so volume is going in the range of petabytes, and we have different variety of the data that comes in. Okay, so what are the different sources of the data? We have a data that comes out from web logs, data coming out from uh, search marketing, data coming out from high definition video, audio, images, right? Sentiment analysis of the consumers, mobile use of the internet, user click stream, right? So many different data finally make up a big data. Now, question we discussed that why cannot we use traditional storage? Okay, because uh, it is really, let's say, now people might ask a question that okay, my business, or let's say a solution which does not require any unstructured data. Okay, unstructured data means can you tell me what is this unstructured data means? Any example of unstructured data? So structured data,
Email,
let me first tell what is structured
email is an example of that, and
emails.
yeah,
Email.
or picture
Okay,
picture data,
right,
like
right,
images.
right. So structured data is something which has got a fixed, defined. Let me, okay, now this is crucial to understand what are different formats of the data that we have, because we'll be talking about a lot once we talk. Like as we move ahead, we'll be talking a lot about structured and structured, right? So let's say we have a data in this format, one, and then we have some name, and let's say age, okay, and seven, something like this. Okay, so what format of the data is this?
Structured
Structure.
data.
This is structured data. Why? Because we have predefined or static schema that this particular data has, right? So we say that the first column is going to be an integer, second one is going to be a varchar or a string, third one is again going to be integer, right? So we follow a same tradition across all. So this is structured data. Okay? If same thing I write it like this, I say one, and then Ram, and then 20 ABC, and then I say 34, and like this. Okay, and second, in the second line I just say 2, chat, something like this, ABCD. And it could be in the third line, it could be something like 4, like this, right? So what format of data is this? Here we don't have any structure, right? We don't know what comes after what. Okay. So first one is integer, second one is character. Now in this case we have again an integer, right? And this has got 4 columns. This one has got only 2 columns, right? So this is unstructured data where there is no fixed number of the columns with the data types. Okay. Now there is also one category which is known as semi-structured data. Can anybody give me some examples? What is semi-structured data? Any example of semi-structured? Semi-structured is something which lies in between of structured and unstructured data. Anybody heard about the semi-structured data?
I think all I can guess is like a Microsoft Word document. It has a structured storage, and you can put any sort of, you can attach any file to that, or email for that purpose. Yes.
Uh, Let me give one example and then we try to relate this. Okay. See, if you talk about a XML file, have you seen the structure of an XML file?
Okay. Remember now. Yes.
Right. So it has got tags and then children tags and then the values inside the tags. Okay. So that
Yeah.
format of the data and then HTML files. Okay. So whenever we have this format in this format, okay, so that is categorized as a semi-structured data. Okay.
Correct.
Is this clear?
Yeah.
So right. So we have these 3 broad classification of the data. So data can be only in the 3 format. Either it will be structured, unstructured, or semi-structured. Okay. Now, the first thing is we have to identify what is the type of the data. So if whenever a request comes for the big data, okay. So the first question which anybody asks is, okay, you tell me what type of data do you have? Okay. Then it starts like what kind of solution we have to suggest, or the rest of the things follows. But the first question that comes up with any problem statement is first define the type of the data that we have, and type is only these 3 that we discussed. So structured data can be either structured, unstructured, or semi-structured. So structured data can be very well placed in the existing RDBMS solutions that we have. Okay. So let's talk about Oracle, which is the favorite of everyone. Okay, so we can store the structured data in Oracle tables, right? We define a Oracle table, okay, and then we load the data in the tables, okay. But can we load unstructured data in Oracle table? Can anybody tell me is that possible or not? Or any RDBMS table, if you're not Oracle, any RDBMS table, can we load unstructured data in those tables?
Images you can store, and in fact, there are data type like XML data type also in databases that you can store.
Where? In which?
But
In which?
like if you see that SQL Server that now supports what do you call XML data types. So you
Right.
can store in a completely, but okay, still I'll not say that it's unstructured.
Hmm. Right.
Mhm.
So even if some of like the latest offering they are coming up with like storage for XML data types and all, right? So, but still, if we talk about the traditional storage, so traditional storage generally means uh, you have a database, you define some static schema, and then you load the data, right? So that is what means with the traditional storage. So none of the traditional system they have a capability to store unstructured or semi-structured data. Okay. So if we have to think of putting this big data, which is of different variety, on using structured the traditional storage, so we have to invest a lot of time into cleaning up of the data, okay, or to make the data in a structured format. So we have to do some sort of pre-processing, right? So if some of the uh, lines it doesn't uh, fall in the static schema, right? So we have to clean up the data if really we have to go with a traditional storage, because traditional storage is something which we are using since last 2 decades, right? So this is one of the biggest concern with the traditional, that it needs a structured and a clean data. So if Oracle, if I have to load some data, let's say my table is defined uh, to have one, I mean, let's say number in the first column, second one is a varchar, third one is again a number. So if my data, by some chance, if the data is something like this, ABC, and then 1, 2, 3, and then this is some A. So as soon as it gets this particular row while loading the data, it throws an exception, and my loading halts there itself, right? So this is the biggest challenge, because if we are talking of petabytes of the data, and we have to cleaning out of the data of the petabytes, is a big challenge, right? So that's the reason why we cannot use the traditional storage for a big data. Now, the second biggest challenge with the traditional system is all the traditional system, like all, like you talk about SQL Server or Oracle databases, right, or SQL or MySQL, whatever it is, it runs on some server. Okay, so it runs on a dedicated server. So if data volume increases, so if I have to increase the size of my, or increase my capability or capacity, so I have to either scale up the cluster, either scale up the size of the server, or I have to put more servers, right? So putting up of a new server or scaling up the size of, or like more volume or more memory, it's a very expensive way. Okay, so if we have to think of using these traditional technologies for petabytes of the data, it's definitely not going to help. Okay, why? Because any server which will have storage for petabytes of the data would need definitely a lot of RAM to load the data. It would need a lot of processing power to process the data, and finally we end up buying a server which are very costly. Okay, so if you have a costly servers, so that finally makes the cost per compute very high, which is never something which is acceptable, right? So everybody wants to have uh, a very cost effective IT solution, right? So that's the reason, even if I'm dealing with a structured data which is in huge volume, right, but still I cannot go with the traditional technology. So this is one of the another reason why a lot of applications which are already working on Oracle forms, Oracle PL/SQL packages and all, so those are again getting, they are facing the performance issues. Okay, even if they have procured very high-end servers and all, even if they are going with a lot of SQL tuning and uh, indexing up of the tables, partitioning everything, but still they are facing the performance hit. Okay? Because whenever the data goes beyond a terabyte, uh, all these technologies they start failing. Okay? This is the reason why most of the applications they are getting moved to the platform like the Hadoop, because they have the performance issues whenever the data volume goes beyond terabyte. Okay. Now, this is a problem with the traditional storage. That's the reason why we have uh, the latest things into the market, which is NoSQL, and then we have the Hadoop. Right. So this NoSQL is to come up with a problem of, um, I mean, it sorts out the problem of a structured data. So if even if we have some unstructured data, like that document type of the data or key value pair of the data, right? So this, all those type of the data, if I have to store, so we have a solution named as NoSQL, which means that not only SQL, right? So it means that it gives me a capability not to store only structured but also unstructured data. And then we have a Hadoop. So in the next class, which is tomorrow, and these are some of the popular NoSQL databases like Cassandra, Hypertable, MongoDB, CouchDB. Each of them have got its own use cases, its own pros and cons, right? So and these are very popular ones like Cassandra, MongoDB, we hear a lot. We have NoSQL databases like MarkLogic also, which is getting a lot of popularity in the community, the enterprise level solutions, right? So in the coming class, which is tomorrow, we deep dive into the Hadoop, okay, and then we'll continue from there. So I would so before we wrap up, any questions so far?
Dheeraj, we are good. I'm good. So hoping that to start doing something soon. But okay,
Right,
it's I understand that this is important to okay, what is the application of what we are going to do? Yes.
right. So uh, can anybody just summarize what we discussed today very briefly? Anybody want to volunteer?
Yeah. So first of all, that why Hadoop or why any big data? So what is big data? We talked about that. That what are the different type of sources of data we have and variety of the data. Then talked about Hadoop framework and say that it has MapReduce, job tracker, task tracker, and HDFS, HBase, and different applications that and different use cases, and then yeah, NoSQL database as you have a slide on right now.
Right, perfect. Right. So yeah, thanks for summarizing that. Okay. Yeah, so we just looked into what is big data, why, what are the sources, multiple use cases, what is Hadoop, how does it came into picture, and then we talked about some of the problems with the traditional system, and then we came to a point where we we understand like what is this Hadoop, what are its scope, okay, and where exactly it fits in, right, in this universe, where exactly this particular Hadoop fits in, what are the use cases that can be served, and why is it coming into picture, because there are so many problems with the traditional way of dealing with the data. All right, thanks everyone. We'll continue our discussion tomorrow.